And it's really important that you get these straight before you start working problem. And it is when the attractions between the solvent and the solute, I'll show you in the diagram. A solution is nothing more than a homogeneous mixture, and they are distributed throughout. That is the whole idea. It's in a single phase. So for example, we've got Gatorade. How would we make that? We would take water and we would add some electrolytes and some glucose and some flavoring and color and things like that, preservative, and we would mix them together. It would be uniform throughout, and that would be a solution. So the parts of a solution are solute and solvent. And it's really important that you get these straight before you start working problems. So the solute is the thing that gets dissolved. And so sometimes it's a solid. Generally in chemistry, it's a solid. We dissolve it in a liquid, and then we would have a solution. The solvent dissolves the solute. Now here is a little trick that I use. The solute is little and cute. The solvent is big as a tent. So the smaller one is the solute, the big one is the solvent. Now, most of the time in chemistry, we're talking about aqueous solutions, but solutions can be in any state of matter. And so I have a common mixture or solution. Bronze is a homogeneous mixture of metals. And then also air is a mixture. It is primarily, it would be nitrogen, so that would be the solvent, if you will. And then oxygen and lots of other gases are distributed uniformly throughout. Now, let's talk about this picture. You will see this picture over and over and over again, so it's really important that you can explain it. So first of all, when do we have a solution? It is when the attractions between the solvent and the solute, I'll show you in the diagram, overcome the attractions of the solute itself. So this is potassium chloride. It's an ionic solid, crystal lattice. You've seen that structure before. So what's going on here is we've got these ionic bonds, right? All the potassium ions are attracting all of the chloride ions. So it's a very strong ionic bond. So here comes water, and that would be these little molecules here. Now remember that water is a dipole. It has a slightly negative end, and that would be the oxygen end, and a slightly positive end, which is the hydrogen end. And so it acts like a little magnet. It's attracted to the oppositely charged particle. And so the oxygen end is attracted to the potassium, and then similarly the hydrogen end is attracted to the chlorides. And so the water molecules attract those ions with a greater force than those ions attract each other. And boom, there you have a solution.